Hello everyone, welcome to the 9th tutorial of Introduction to ArcGIS. Today we will talk about Project 3, which is based on interpolation. So let's start. This is the detail of our Project 3. We are given a DEM model, a fault line, a water level which is an Excel file, a river in vector, a water body in vector, and the boundary in vector file. With this, we have to generate a flat map and classify the flat as per the FFWC category. So let's work on that. At first, we need to export our water level Excel file in CSV format. For that, we will select it and we will export this as CSV file. After that, we will import all the data we have in ArcMap. As we have the data in CSV format, we have to make it in XY format. For this, we will go to the display XY data, select the X field as point X, Y field as point Y, and Z field as point Z, and click OK. Whenever we got the XY data, we will have to make it as shapefile. For that, we will go to the export data and select as shapefile. Now we have the flat level data as a shapefile. Now we will work with the interpolation of our DEM. For that, we will go to the spatial analysis tool and then interpolation and IDW. In the IDW, we will select our flat level XYZ input point as input point feature. In the Z value field, we will select shape.z. We will rewrite the output cell size as 300 and keep all the data as it is. We will select the input barrier polyline feature as the fault line. Next, we need to work with the environment. In the environment, we will go to the processing extent and select the extent as the DEM. And select the snap raster as the DEM also. Next, we will go to the raster analysis and select the DEM as the mask. Click OK. Now the interpolation will begin. It may need a very long time, so we will have to wait for a bit. As we can see, the IDW has been finished and we get our desired result. Next, we need to do an operation. As we know, the DEM is the elevation of the earth and the IDW is the height of the rainfall. So, if we subtract both, we get the Z value. For this, we will go to the map algebra and click raster calculator. From the IDW, we will minus the DEM model. And from this, we will get our desired result. Next, we need to classify it. For this, we will go to the property and go to the symbology and classify it. We will select the class as 6 and go to classify more for more detail. As we can see, we have classified it as 0, 0.3, 0.9, 1.8, 3.6 and 10.5 as break values. We will click OK and select a color ramp and apply it. As we can see, this is the subtraction value of our calculation. Next, we need to classify our limits as a new value. So we will go to the reclassify. In the reclassify, we will input our raster and go to the classify for more detail. We will select the classes as it was and set the break values as it was. As we can see, the break values are in their previous form. We will click OK and the new value will represent the previous value, which is 1, 2, 3, 4, 5, 6. As we can see, this is our reclassified value. Here the green means there is no flat. Next, we need to work with the attribute table. For this, we will go to the attribute table and we will create a new field which will be the area of the particular type of the flat. We will go to the field calculator and we will calculate the area as the cell size into the count divided by 10,000. From this, we will get our desired area. Next, we need to do some identity. For this, we have to make this raster into polygon. For this, we will go to the raster to polygon tool. We will input our desired raster and choose the field as object ID. Here we have our polygon version of the raster. Next, we will go to the identity tool and select this feature as input feature, and as identity feature, we will click the Thana boundary. Next, we will click OK. So this was our desired result. Next, we will answer the questions. As we have already created the flat map and classified the flat as per the FFWC category. So question number 1 has been answered. Next, we have to find out the flat statistics for each category. For this, we will go to the attribute table of our last identity result. We will select on and copy and paste it into Excel. Next, we will insert a pivot table. In the pivot table, we will click the grid code as rows and the sum of shape area as values. Here, the grid means the flat labels and the sum of area means the area contained in that label. And we can get our number 1 question's answer. The next question is identify the extent and magnitude of flat for each Thana and generate statistics. For this, we will work with the same dataset. In the pivot table, if we select the grid code as columns and the Thana name as rows and the values as shape area, we will get our desired result. The next question is show settlements under various flat categories. For answering this question, we have to go to the ArcMap again. To calculate this, we have to work with the identity tool, but in this session, we have a point feature. So we will have to use the spatial join tool. In the spatial join, we will use the previous identity feature as target feature and the new point as join feature. Whenever we get our desired result, we will go to the attribute table and copy it and paste it into Excel. Next, we will go to the pivot table. And in the pivot table, we will select the grid code as columns and the type as rows and the area as values. And if we percentage it, we can get our desired result for each town and village. The next question is we have to compose an A4 size map showing the flat extent and magnitude for each upazila of eastern Bangladesh. As our previously learned tutorial, we have made the map according to our need. We used a new tool which is data driven page. Next, we will go to the export map and select the save type as PDF. Go to the pages and select all and click save. And we can see that all the pages have been created as a particular map. Thank you for staying with me for the whole time. I hope we learned something from this video.